Yes, so now we move again to the next concept from this, that is, we'll start with our main binomial expression, that is a plus b raised to n. So what is a plus b raised to n? It is nc0 a raised to n plus nc1 a raised to n minus 1 b raised to 1 plus nc2 a raised to n minus 2 b raised to 2, like this. Now suppose we substitute here a is equals to 1 and b is also equals to 1. So what happened to this? This become 1 plus 1, so that become 1 plus 1 raised to n. This become nc0 1 raised to n, nc1 1 raised to n minus 1 1 raised to 1, nc2 1 raised to n minus 2 1 raised to 2, and so on. So which is nothing but what? It is left hand side become 1 plus 1, so it is 2 raised to n. And the right hand side become what? nc0 plus nc1 plus nc2 plus the last is ncn. And that are nothing but the sum of the binomial coefficients are always equal to 2 raised to n. We can just verify this in the Pascal's triangles also. My Pascal's triangle is 1 1, next is 1 2 1. 1 3 3 1 1 4 6 4 1. So if you observe the sum of the coefficient here, that is 1 plus 1, that is what? 2. So it is nothing but 2 raised to 1. 1 2 1, sum is what? 4, and 4 is nothing but 2 square. This is 2 cube, 8, this is 16, so it is 2 raised to 4. That is depending on the power of the expression. The sum of the coefficient is always become like this, 2 raised to n. Now the same concept is valid. The same concept is valid for if you take a is equal to 1 and b is equal to minus 1. If you take a is equal to 1 and b is equal to minus 1, this expression become alternate plus minus sign. The same expression become alternate plus minus sign. So it is nc0 minus nc1 plus nc2 minus nc3 and so on. So it is clearly from this, the left hand side becomes 0. So 0 is equal to nc0 minus nc1 plus nc2 minus nc3 and so on. So the even term keep in the right hand side, or you take this side. So nc1 plus nc3 plus nc5, nc0, nc2, nc4, like this. So what is that? 1, 3, 5, 0, 2, 4. The sum of all coefficients, sum of all terms, coefficients is always equal to sum of even terms coefficient in this. That is always equals. So that is it. Suppose we assume this is equal to x. Suppose we assume this is equal to x, then we just derive nc0 plus nc1 plus nc2 plus nc3 is equal to what? 2 raised to n. That is nothing but this left hand side and right hand side. It is become x plus x. The addition of this two, that is nothing but 2x. So 2x is equal to 2 raised to n. Therefore x is what? 2 raised to n minus 1. That means, so we get a formula here. So what is the formula? nc0 plus nc2 plus nc4. In fact, nc1 plus nc2 plus nc3, like that, ncn is 2 raised to n. And if you take even power, it will be what? 2 raised to n minus 1. Or it is 2 raised to n minus 1, like this. Though in sum of all it is 2 raised to n, only even it is 2 raised to n minus 1, or it is like this, 2 2 raised to n minus 1. So that is the expression. Now here, instead of this, if you observe this, the n is common in all. The same formula can be written as, because there is the n is common, so there is no need to write n every time in the expression. Instead of that nc0 and c1, we can write the same as capital C0, c1, c2, like this, cn. So that is nothing but it is understandable. That is equal to what? 2 raised to n. Similarly, so c0 plus c2 plus c4 like this is what? 2 raised to n minus 1, c1, c3, c5. So there is no need to write n every time because it is understandable by the coefficient. But remember, in this, it always starts from 0 and always end to n. What is the starting point? There is nc0. And what is the end point? It is the nc, and then there become 2 raised to n. So based on this very simple questions which is there in your textbooks, you will solve that few sums. So exercise 4.5. Now a few questions based on exercise 4.4, that is the same concept. So here exercise 4.4, question number 1, show that C0, C1, C2 up to CA is equal to 256. Now this you have to prove. So how to prove this is very simple. Start from the left hand side. LHS C0 plus C1 plus C2 up to C8, and that is given by what? It is equal to 2 raised to 8. The reason is since C0, C1, C2, Cn is 2 raised to n, and therefore it is 256, and that is right hand side. So it is proved. Similarly, next, question number 2, C0, C1, C2 up to C9 is equal to 512. This you have to prove. So we can say LHS is equal to C0, C1, C2, C9. Same way, it is 2 raised to 9, so it is 512. That's the right answer. So it's very easy to prove. Understood? But be cautious here. Suppose sometime they may ask you, or they may test you in this way. The third sum is, it is given that C1 plus C2 plus C3 to C7, you have to prove that it is 127. That is in question 3. This you have to prove that it is 127. So now how to prove this 127? If you look at this, and let's just C1, C2, C3, C7. Now, it is not started from C0. Remember that the formula is valid when it starts from C0 to Cn. Here this is not started from this one. So therefore, you have to add and subtract C0. C0 added and C0 subtracted. So this become what? It has become 2 raised to 7, and C0 value is 1. So it is 128 minus 1. So it is 127, and that is right hand side. So it's very easy proof here. So all the rest is almost same. So the last one, that is question number 7 in this. So we will solve that question. This 4. Exercise 4.5. So last question, question number 5 in this. So question number 5, sorry, question number 7 in this. This question number 7, C0 plus 2C1, C0 plus 2C1 plus 3C2, like this. N plus 1 Cn. You have to prove that is equals to, you have to prove that is equals to n plus 2 into 2 2 raised to n minus 1 into 2 raised to n minus 1. Now this you have to prove. So we'll start with LHS here. So LHS is equals to left hand side. So what is the left hand side here? C0 plus 2C1 3C2 like this n plus 1 Cn. Now we will make a 2 bracket now. C0, C1, C2 up to Cn. That is one bracket. And another bracket plus C0 is taken here, so there is no need to write again. But C1, one C1 is taken, 2 C1 is there, so that become C1. Similarly, एक गया C2, तो 2 बचेगा, so it is 2 C2. Like that, 3 C3 and last में बचेगा N Cn, like this. Now what is the value of this? C0 to C0 plus C1 plus C2 plus C3 up to Cn. The value of that is 2 raised to n. It is what? 2 raised to n. And what is C1? C1 is nothing but NC1. So NC1 is nothing but n. It is n. 2C2 is nothing but 2 into n minus 1, 1 into 2. Similarly, 3C3. So it is 3 n minus 1, n minus 2, 1 into 2 into 3. Like this, the last is NCn. So NCn is equals to what? N into Cn. So n into 1. Like this. Now we observe this, we can take n common terms. N is there everywhere. So it is 2 raised to n. We take n common here, 1 plus. Now this 2 and this 2 is out and n is out. So what is remain there? It is n minus 1. Similarly, this 3 cancel, n is taken common. So what is remain here? It is n minus 1, n minus 2 upon 1 into 2. Plus, like this, n common, so last में बचेगा वापस 1. And that is nothing but 2 raised to n plus n into, what is this? We can say it is C0 plus n minus 1 C0. It is n minus 1 C0, n minus 1 C0, n minus 1 C1, n minus 1 C2. The last one, n minus 1 Cn minus 1, like this. So which is nothing but 2 raised to n plus n into 2 raised to, whatever the power is here, that is 2 raised to n minus 1. Now 2 raised to n minus 1 is nothing but 2 raised to n minus 1 is nothing but we can take 2 raised to n as common in this. So it is 2 raised to n. 2 raised to n split into 2 into 2 raised to n minus 1. This is n into 2 raised to n minus 1. We split 2 raised to n as 2 into 2 raised to n minus 1. And 2 raised to n minus 1 we will take as common as 2 raised to n minus 1 make common. So अंदर क्या बचेगा n plus 2 and that is your right hand side. So like this it is proved. Understood, beta? So it's very simple expression in this. So you have to remember. That's whatever concept we discussed till now, and we solved a few sums based on the board textbook. Now the same concept is valid for the JEE also. So we will solve now the question based on JEE MAINS, as well as when additional concept is there, it can be discussed during that particular questions, whenever the questions will come, and that we will discuss. So we will start now with JEE MAINS point of view. So now we will solve here some based on this, that is a concept of coefficient, the sum of the coefficient formula. So here the question number 22, what is the value of this 10C1, 10C3, 10C3? Clearly it is an odd coefficient. The sum of odd coefficient is always equal to 2 raised to n upon 2, that is 2 raised to n minus 1 we can say. Here n is So formula is 2 raised to n minus 1. That's the formula. Here the value of n is equal to 10 because this is the value. The n is equal to this. That is n is equal to what? 10. So n is equal to 10. So this becomes 2 raised to 10 minus 1. So answer should be what? 2 raised to 9. The sum of this is given by 2 raised to 9. The next question, question number 23 is given that what is the value of this? It's 14C1 plus 14C2 plus 14C3 up to 14C14. Now remember that here we have not started with 14C0. 14C0 से start नहीं हुआ है. You have to add 14C0. You have to subtract 14C0 here. So that is 14C0 plus 14C1 plus 14C2. Like this 14C14, you added this, you have to subtract this, is 14C0. So now this particular thing we can say it is 2 raised to 14 and this is minus 1. So answer is 2 raised to 14, that is 2 raised to 14 minus 1, that is next, a small concept of J point of view, that is they will ask you to find the sum of coefficients. So sum of the coefficient here, so we know that for a plus b raised to n, the expression is nc0, a raised to n, nc1, a raised to n minus 1, b raised to 1, nc2, a raised to n minus 2, b square, like this nc b raised to n, that is expression for this. Now here we put a is equals to 1 and b is equal to 1. If we put a equal to 1 and b equal to 1, then the left side become 1 plus 1 raised to n, but the right side, the power of a and power of b remains same because it's 1 only. 1 raised to anything is 1 and therefore this becomes nc0 plus nc1 plus nc2 plus ncn. And that is nothing but C0 plus C1 plus C2 Cn, that is equal to what? So that is nothing but the sum of coefficients. Sum of coefficients is equal to what? 2 raised to n. So what we have got, what is the concept here? Whatever the variable is, whatever the variable in the expression is x, y, or a or b, you have to put that value is equals to 1 to find the sum of the coefficient. So in question number 24, they ask you generally, the question 24 of generally, that is the sum of the coefficient for 1 plus x minus 3x raised to what? 2160. Raised to 2160. 1 plus x minus 3x raised to 2163. In this, they ask you to find the sum of coefficient. For sum of coefficient in this, remember that put x is equals to 1. That will give you 1 plus 1 minus 3. So that is clearly from this. And 2163 is a odd number, so answer should be equals to what? Minus 1. So the sum of coefficient. So here you should remember this concept, that is sum of the coefficient, you have to put the variable is equals to 1. Next, very simple sum here. Question number 25, it is C0 minus C1 plus C2 minus C3 plus minus and the last one minus 1 raised to n Cn. So it's clear cut when the ultimate plus minus sign is there. The sum of odd coefficient and sum of even coefficient in the binomial expansion is always same, and therefore that will get cancelled out. So it is cancelled out. C0, we can say C0 plus C2 plus C4 in bracket and another bracket C1 C3, and the value of this expression and this is same, so answer is 0 for this. Next question, question number 26, C0 C plus C2 plus C4, up to this the term is not given, so here it is clearly sum of even coefficients. So even coefficients is, sum of even coefficient is what? It is equal to 2 raised to n minus 1, because whatever this power is there, you will divide by 2. So it is 2 raised to n divided by 2. Next question, that is question number 27. What is the value of this? C1 upon C0 plus 2C2 upon C1 plus 3C3 upon C2 plus NCn upon Cn minus 1. So what is the value of this expression? That's the question. So now here we can easily say C1 is nothing but n. So it is n upon C0 is 1. 2 into C2, what is that? 2 into n into n minus 1 upon 1 into 2, and C1 is n. Next 3, so 3 into n minus 1, n minus 2, 1, 2, 3 upon C2. C2 is what? n into n minus 1, 1 into 2, like this, and so on. So I'm not writing the last one because it's understandable if you got this 2. So here n and n get cancelled. This 2 and this 2 get cancelled. So remain is what? N. The next one is remain is what? N minus 1. What is this here? See. 1 into 2, 1 into 2 cancel. 3 cancel. N into n minus 1, n into n minus 1 cancel. So next term is what? N minus 2, n minus 3. Like this, it is 1. So which is nothing but it is, if you write in the reverse direction, it is 1 plus 2 plus 3, n minus 2, n minus 1, and the last is n. That is nothing but the sum of n natural numbers. The sum of n natural number is n plus 1 upon 2. So your answer should be what? n plus 1. Next question, question number 29. There is C1 plus 2C2 plus 3C3. What is the value of this? So again the same way, C1 is as it is, C1 is n. 2 into C2, that is nothing but 2 into n minus 1, 1 into 2, plus 3C3, that is 3 into n minus 1, n minus 2, 1, 2, 3. So it is continued like this. 4 n minus 1, n minus 2, n minus 3, 1, 2, 3, 4, and it's like this. So last is NCN. NCN is always equals to, it is n into NCN, n into CN, so it becomes n. So now it is clearly from this 2 and this 2 cancel, this 3 and this 3 cancel, this 4 and this 4 cancel. If you take n common, so अंदर क्या बचेगा? n common लेने के बाद it is 1 plus n minus 1 plus n minus 1, n minus 2 upon 2 factorial, like this. N minus 1, n minus 2, n minus 3 upon 3 factorial plus 1. So it is like this. So n, if we n common, so it is nothing but n minus 1 C0, n minus 1 C1. So we can say it is the n minus 1 C0, n minus 1 C1, n minus 1 C2. The last is n minus 1 C, n minus 1. So that is n into 2 raised to n minus 1. So your answer should be this, n into 2 raised to n minus 1. That is the final answer. Question number 30 is a simple formula. There is nothing in that. The sum of the odd powers. So odd power का sum जो है, even power, the sum of odd power coefficient and sum of even power coefficients are equal. So it is always given by 2 raised to n upon 2, so it is nothing but 2 raised to n minus 1. So that is the answer for question number. Next question, question number 31. That is find the sum of the coefficients. So what is the sum of the coefficient in this? So it is very simple. Put x is equals to 1. So that will give you 1 square, 1. 3 by 9, so again the same. is odd power. So answer is what? -1. Yes, so next question number 32 in this, you have to find this value. C0 plus 2C1 plus 3C2 plus 4C3 like this. So in this, if you take one term C0, C1, one each term here in this bracket out like this up to Cn. One term is taken out. So what is remain? One is gone here. In the second bracket it will be 1, C1. It will be what? 2C2. Next it is 3C3. The last one is NCN. So it is like this. So what is the value of this? It is nothing but 2 raised to n. What is this one? C1 is nothing but always n. 2 into C2. So 2 into n minus 1 upon 1 into 2. 2 factorial, that is 3C3 is 3 into n minus 1 n minus 2 1 2 3. Like this. The last is n. So we take n common out of this. So it is 2 raised to n plus n common. Andar kya bachega? 1 plus this 2 and this 2 cancel. So n is taken out 1. The next term will be what? n minus 1. Uske baad n minus 1, n minus 2. If you just observe properly, this 3 and this 3 cancel, n is out. So it is 1 into 2. Similarly, the last way, n common, so it is plus 1. So, which is nothing but 2 raised to n plus n into, what is this? It is a n minus 1 C0, n minus 1 C2, n minus 1 C2, and that is n minus 1 C, n minus 1. So, it is 2 raised to n 2 raised to n minus 1, like this. And 2 raised to n minus 1, 2 raised to n we can split as 2 raised to 1 into 2 raised to n minus 1. So, 2 raised to n minus 1 we get a common here, and that become n plus 2. So, 2 raised to n minus 1 into n plus 2, that is the answer for this question 32. Yes, so next question, question number 33. So there is same question, this alternate plus minus sign is there. So method of solving is the same, but answer will be different. So see what is answer in this. C0, then we write this as minus C1 plus C2 minus C3. So one term we take in this. So like this, whatever the minus 1 C minus 1 raised to n Cn will go there. And then what is remain in the another bracket? Another bracket it is एक इधर चला गया तो बचेगा minus C1, इधर एक चला गया तो 2C2, इधर 3C3, like this. Last में बचेगा minus जो भी करेगा minus 1 plus 2n. So it is NCn में लिखता हूँ. The power of that sign we don't know what is plus or minus, it may be. So now this is there. Now this is clear cut. The sum of odd even it is what? 0. And what is this one? If you take a minus common out of this, so it is C1 minus 2C2 plus 3C3 minus like that. So it is minus of C1 is nothing but n. This is n into n minus 1 upon 2 factorial. This is 3 into n minus 1, n minus 2 upon 1, 2, 3. Like this. So now n is taken common. So that is minus n in the bracket, and this 2 and this 2 cancel. So it is 1 minus n minus 1. This 3 cancel, n is out, so it is n minus 1, n minus 1, n minus 2, 1 into 2, like this. So that is nothing but minus n, this is n minus 1 C0, minus n minus 1 C2, n minus 1 C2, C1, C2 like this. So it is minus. So it is again now plus minus, alternate plus minus is coming. So it is going to be what? Minus n into 0. So answer should be what? 0. Because the expression where is this type, but when plus minus in this, the sum of the coefficient is going to be 0. So 0 into minus n, that is equal to 0. So next question is question number 35. From sum of the coefficients. So sum of the coefficient, we put x equal to y equal to z is equal to 1. This become 1 plus 2 plus 1 raised to 10. That is 4 raised to 10. So what is 4 raised to 10 that we have to calculate? So it is given there. So option is this. So this is the answer. 4 raised to 10. The question number 35 answer is 4. Yes, the question next question number 36. Before that, there is one simple concept of combination, that is NCR minus 1 plus NCR is always equal to n plus 1 CR. So remember that this is a formula for the binomial coefficient. So this is always equal to n plus 1. What is the meaning of this? 3C2, 3C3, so that become what? 4C3. This, what is this one? You have to add 1 in this, n plus 1 CR. 5C3 plus 5C4 is equal to what? 6C4. Like this. This, and then we will add in this, n plus 1 CR. N plus 1, you have to add 1 power here, and highest of these two, but that 2 should be what? Consider that, don't forget that. So this is a very simple formula. Simply 8C3 plus 8C4. What should be this one? It should be equal to what? 8 को आगे बढ़ाना है, 9 दोनों में से बड़ा लिखना है. So that is 9C4 like this. Yes, the next question number 38. NCR plus 1 plus NCR minus 1. So it's 2 NCR. So here we write this 2 as we split it. So it is NCR plus 1, NCR minus 1, NCR plus NCR, like this. So clear cut form this, if we add this 2, it is 2 consecutive and the power the value of 10 is n. So it will increase that n with 1. That is, next is n plus 1. And दोनों में से highest लेना है, so R. So like this. So it is an NCR. Similarly, this and this can be added here. In this 2 consecutive again. So it is NCR plus NCR plus 1. This is as it is. N plus 1 CR. What is the answer for this? It is n plus 1. It is n plus 1 CR plus 1. And that is n plus 1 CR. So again now this becomes 2 consecutive. So further we extend it. So it is n plus 2 CR plus 1. So answer is n plus 2 CR plus 1 for question 38. Next, question number 39. It is 50C4 plus summation R1 to 6. 56 minus RC3. So in this case, what will happen? In this, you put R equal to 1, 2 like this. So this become what? 50C4. Put R equal to 1, so that become 55C3. Then 54C3. Then 53C3. Like that, 52C3, 51C3, and the last is 50C3. Because when R equal to 6, the last one will be 50C3. So now, 50C3 and 50C4 added. So if you write this in that way, that is 50C3 plus 50C4 is added. Then 51C3, 52C3, 53C3, 54C3, 55C3, and 56C3. So, sorry, 55 is the last one, so 55C3, like this. So what is the addition of this? Is 51C4. It is 51C4. When 51C4 added in 51C3, that become 51. So it is as it is 55C3. So this is not 52C4. 52C4. This become 53C4. 53. Now it is 54C4. Like this. 54C3. The last is 55. So now this becomes 55C4 plus 55C3. So final answer should be what? 56C4. It is just use the same formula, same technique. The same is a consecutive coefficients and but it add them like that. So NCR minus 1 is n plus 1 CR. Using that formula, we will do that. Next, question number 40, again the same concept here. 50C11 plus 50C12 plus 51C13 minus 52C13. So now the addition of these two will, so two consecutive, dono per same. So this is the next one, that is 51C12 will come. So same again, two consecutive, so it is what? 52C13. This 52C13, 52C13 is cancelled out. So answer is 0 for this question 40. Answer. There are certain questions which is very difficult to solve intuitively by traditional method, that is very lengthy. So we may have left few questions which that we will discuss in the next lecture. Whichever question number 28, 34, 40, when I know that I have not solved it, because it is traditionally very lengthy method, so that can be solved by some shortcut method, and that will discuss in the next lecture. In the next lecture, that is shortcut trick of binomial theorem.